For the 9 cups of coffee, which is composed of Olivia, me, Riji, and Connor, and we're going to present to you our electric Porsche bus design. So the main problem in Sparkyville is the population, tourism, and infrastructure is rapidly increasing, and citizens want a more efficient and cleaner transportation method that can accommodate larger groups. So the main issues are there's an excessive environmental harm, expensive outdated hardware in use, and a limited capacity for personal items. We also don't have enough seats for larger families, and the safety of passengers is a concern. And most of the transportation systems right now are inclined to accommodate only one audience. Our design requirements includes an $80 budget. Solar panels must be incorporated into our design, and it must accommodate at least 3 passengers and their luggage. We also must include a way for the car to stop and respond to the traffic lights, and it must move at least 20 Sparkyville blocks. And it must be able to fit in our lockers and must be able to be assembled and deassembled easily. So in our design, our safety features include an RGB sensor which will tell the motors to stop when it's a red light, and we include handrails, much like a trolley or a bus. And our solar panels are used because it's a clean, renewable energy, and which reduces pollution, and it also enables cheaper transportation for the service providers and the passengers. And it also allows the vehicle to be charged while it's being driven.
In our experiments, we wanted to test the greatest yield for our solar panels. We tested them for their current and their voltage, and we found that solar panel 2 yielded the greatest combination. We were also inspired by the continuously variable transmission, which operates on the principle of changing the load speed to render peak torque. We also wanted to employ a good counterweight balance, so we employed a rear engine and rear-wheel drive setup similar to a model Porsche 911.
Based on our experiments 1 and 2, we chose panel 2, which is the highest voltage and current yield. The panel 2 was the 112 millimeter by 84 millimeter solar panel. Our car will be rear-wheel drive, and it will have rear-mounted motors, which will create a higher weight on the driving wheels and give us more traction on the car. We'll use a 3-4 gear ratio, which was determined from experiment 3, and along with the 3-4, we will be implementing a 2-3, which are 2 gear ratios that produce the highest RPM. We'll have a CVT type configuration in order to combine the power of 2 different motors, and we'll have handrails for the passenger safety. Design 1 is a bus shape. The primary materials of the body are balsa wood. It will be a 3-4 gear ratio. There will be 6 solar panels with the size 130 millimeters by 150 millimeters. They will be located with 2 on the top and 2 on each side. The inside is large and spacious. All of the electronics will be located on the bottom of the car, and it is rear-wheel drive with 2 motors. Our budget for this design is $92.09. Design option 2 is another bus shape. The body is made out of balsa wood and cardboard. It is a 3-4 gear ratio. There are 3 solar panels on this. The size of the solar panels are the 112 by 84 millimeter solar panels. There will be 2 on the top and 1 on the front. There is a lot of space on the inside to accommodate for passengers and their luggage. It is front wheel drive with 1 motor, and our budget for this design was $55.12. Design option 3 is a wide bus shape. The body of the design is made from cardboard wrapped in duct tape in order to create a waterproof product, and our bottom area supporting the car is going to be made out of cardboard and a reinforced balsa wood plate sitting above the wheels in order to hold the motors and create more stability. There are 6 solar panels panels, and the solar panels we're using for this design are the 112 by 84 millimeter panels. They will all be placed on the top. This is rear wheel drive with 2 motors, and all of the electronics will be on the bottom. And the budget is $74.39 for this one. An analytical hierarchy process, or an AHP, is a diagram in which we are able to compare our criterias in order to find out which of the criterias have the most weight in when we choose a design. Our criteria are budgets, volume capacity, power, safety, and passenger accommodations. Based on our diagram, our highest weighted were budget at 32.9% and safety at 29.7%. Our design matrix gives us a way to compare our criteria to how well each of our designs fits into that. Using the weight percents that we determined from our AHP, we are able to take each design and rate them based on how well they abide with our criteria, and then give them a score. Our highest rated is the best design for the application.
Our design 3 was the best design, and it's called the Porsche Bus. And as you can see right here, this is our orthographic drawing with the side view, the front view, and 2 top views. The side view shows the wooden dowels, which are our frame or chassis, and the wooden dowels are also used for our the wooden dowels are also used as our support beams. The bodies mostly made out of cardboard reinforced with duct tape, and our RGB sensor will be on the top, right in front of the solar panels. Right here you can see a visual of how the frame will be configured, which is going to be the wooden dowels stacked on top of each other to maximize the length of the bus and also the structural integrity. The front view shows the door and the space inside of the vehicle. The door will act like a ramp, much like a wagon, which you can see right here. And furthermore, you can see the top view of the vehicle with the 6 solar panels arranged in a parallel style, and which will maximize the power output. And this is the top view with just the frame and the motors. You can see the 2 motors, which are supported by the balsa wood, and the motors have a 4:3 and a 2:3 ratio attached to the axle, which are connected to the wheels. This is our proposed design activity diagram, and it starts off with the sensor searching for light. If it does not sense light, it will keep repeating and will keep searching for light. If it does sense a light, it will identify the light, and if it's green or yellow, the car will continue to go. If it's red, the sensors will tell the motors to stop, and if the motors stop, the car will stop. If the sensors tell the motors to stop and the motor does not stop, the driver will engage the manual brake, and which would basically be us stopping the wheels. So our proposed design is a body-on-frame design, and it has the dowels will be stacked on top of each other so that it will maximize the structural integrity but will minimize the weight. The body will be made out of cardboard and will be held together by duct tape, which will again maximize the integrity but minimize the weight. The motors, there will be dual motors mounted in the rear of the vehicle, which will balance the weight distribution whenever there's passengers in front of the vehicle. We'll also integrate CVT style gears, which will increase the RPM of the motors. And there's also going to be handlebars for safety, which have a dual purpose. And we also have bench seats that face each other so that passengers can interact with each other. We also have 6 solar panels, which will maximize the power output, and the luggage is stored and strapped next to the passengers so that the passengers will be able to access it easily. And here's our materials list, which in totals in to $74.39, which is below budget.
To arrive at a predicted top speed, we first took our estimated angular velocity of our drive shaft multiplied it by the circumference of the wheels, divided that by 60 seconds per minute to arrive at an estimated top speed of 440 inches per second in translational velocity.
Electric Porsche is our best design as it satisfies the mayor's and most of the citizens' requests. It uses 6 solar panels in order to supply a large supply of clean, renewable energy. The car can seat a large number of people while still having room for all the passengers' luggage, while still remaining under the given budget.